Okay, welcome back. I'm just going to pick up where we left off with question 15. So we're given that this function f of x is defined for all x greater than 0. So we only know what's happening on the positive x-axis, but we know that it's defined for all x greater than 0. And the line of y equals 4 is a horizontal asymptote. Which of the following must be true? So let's just analyze each of our answers as we go down. So starting with A, f of 4 is undefined. Well, that may not be necessarily true because at 4, where x is equal to 4, we could have a function that does something like this as it approaches this asymptote. And that means that where x is equal to 4, we have some y value where we have f of 4. And that's perfectly fine. So we can say that f of 4 is defined. We can make a situation where f of 4 is defined, so that's not necessarily true. So we can cross off A. Let's see, we have f of, for answer choice B, we have f of x is not equal to 4 for all x greater than 0. Now we also have the case where we can have a horizontal asymptote like this, and our function can cross the horizontal asymptote there. Um, because what the horizontal asymptote is only telling us is about the end behavior as the function goes towards positive or negative infinity. So it won't reach that value as it goes towards positive or negative infinity. However, somewhere in between, it can cross it, like we see here. So B is not necessarily true either. So in this case, I could draw a function that, say, looks like that, and that would be perfectly fine. Now, what about C? The limit of f of x as x goes to infinity is equal to 0. Well, um, because of our horizontal asymptote, our asymptote is telling us about the end behavior as x goes towards positive infinity. So we can't really have that the limit, for whatever reason, just decides to jump down towards uh, 0, because then we wouldn't define our asymptote to be approaching 4. So C is not an option. I'm going to skip over D for reasons. And f of 4 cannot be equal to 0. This answer doesn't really make sense because I can again draw a function such that if I use this graph, f of 4 equals 0, well, I could draw a function that looks like this, and it'll satisfy our criteria, and it'll go through 4, and uh, f of 4 here, our y-coordinate, would be equal to 0 if it lies on the x-axis. So the only option that leaves us is answer D. And that makes sense because, again, if our horizontal asymptote is defined at y equals 4, then kind of by definition of our asymptote, as x goes towards positive infinity, our function will approach this line. And it'll get infinitely close to it. It doesn't necessarily equal 4. However, that does leave us with answer choice D. Let's see, and my camera keeps on focusing. Okay, I couldn't figure out how to fix that. Anyways, um, let's see. So let's move on to question 16. We're given the line y is equal to a as a horizontal asymptote of g of x for all x less than 0. So which of the following must be true? So this is similar to the previous question. Now we don't really know what's happening on the right-hand side of this function. We just know that on the left-hand side of the y-axis, we have a horizontal asymptote at y equals a, and so it doesn't really matter where a is. This should be perfectly fine if we put y equals a right there. And so again, we try to figure out what must be true. And so let's compare what we had for the answers up above. G of A is undefined. That's pretty much like answer A up here. I can make where x is equal to A right here. This point, if we have a function, I don't know, that comes down like that and approaches that asymptote, if our function has a point right there, then this point right here will have where x is equal to a, g of a can be defined right there, and that's perfectly fine. For all x, or for any x, can't be equal to a. This is again pretty similar to answer choice B. And for reasons that I explained before, we can make a situation where we can cross the horizontal asymptote. And as long as the end behavior is that it gets asymptotically close to the asymptote, then we're perfectly fine. So answer choice B is eliminated. As so the limit for g of x as x goes towards negative infinity. Well, as we go towards negative infinity, so yes, we do need to go in this direction, approaches a. Well, our asymptote is defined as a, so our function does need to approach it, or else we wouldn't define our asymptote as y equals a. So that's a pretty good contender, possibly even the right answer, hint. However, answer choice D, as for g of x as x goes towards negative infinity, g of x is equal to negative a. Well, that doesn't really make sense for our function to be approaching a, or us to define this asymptote for y equals a, and then all of a sudden our function jumped down towards negative a for no real reason, because then we wouldn't define our asymptote to be y equals a. So that eliminates answer choice D. And E, saying none of the above, generally in my experience, none of the above is hardly ever the answer. And especially when we have an answer like C, that would be incorrect. So C is definitely always true. As g of x, as x goes towards negative infinity, g of x will approach a if we have an asymptote there. That's what we define our asymptote from, is the end behavior. And so question 17, this is pretty similar to our polynomials, but describing the end behavior that we had for those. So we want to figure out what happens for x, or for our function, as x goes towards negative infinity. Well, what is our function doing? Our function is going downwards like that. So f of x is going down. And so we describe that type of behavior with the limit of f of x as x goes towards negative infinity. F of x is going down also towards negative infinity. So just looking at that, that already eliminates answer choices B and answer choices D. And f of 0, well, f of 0 is 2. And so that, I mean, answer choice E is not even really a contender for any of this. So really, that already just leaves us with answer choices A and C. So now we just have to evaluate, well, what's happening as x goes towards positive infinity? Well, as x goes towards positive infinity, notice that it just keeps going up and up and up. It doesn't stop. So f of x, on the other hand, over here, just keeps going up towards positive infinity as well. And so we also have the limit of f of x as x goes towards positive infinity is equal to positive infinity. And so that eliminates answer choice A, which leaves us with answer choice C.